Welcome to Electromagnetic Online tutorial. Now before us is this electrolysis question, and it shows that in copper plating, a current of 0.5 amperes is allowed for a cathode area of 100 centimeter square. Now if this current is maintained for 100 minutes, what is the approximate thickness in meter of copper deposited? In this case, we are given that the electrochemical equivalent of copper here is given as 0.0033 gram per coulomb. Now the density of the copper is given as 10 raised to the power of 4 gram per centimeter cube. So first and foremost, all we just need to do here first is to write out the parameters given in the question. Now we're given that the current I is given as 0.5 amperes. Now the area of the plate, that's A, is given as 100 centimeter square, and the time T is given as 100 minutes. Okay, and we are told that we need to find the thickness in millimeter, and take note, if you notice, all the units here are in centimeter. Okay, deposited. Now we are given that the density of the copper is given as the 10 raised to the power of what? 4 gram per centimeter cube. Right, this is the symbol for density, rho. Okay, then Z, the electrochemical equivalent of copper, 0.00033 gram per coulomb. Okay, so what do we need to do here first? We need to find or recall the formula that gives us the relationship between all this. Okay, and that is first of all, that is mass rather. The mass equals Z cube. But we have the problem here. Now the problem is, in this parameters given here or listed here, we don't have mass. Okay, but however, we can get the quantity of electricity by the product of current and time. Now density. Now, so how do we go about it? Now, first of all, we will need to also recall some other formulas, okay, that are interconnected with one of the parameters, okay, for us to start going through. Now, since here we have the density and we have the area, and here we have mass. Now, let's take note that the density itself, rho, is given by the area mass over volume. Okay, so and since we're not given the mass, let us make M the sort of relation here. Now giving us that M will give us what? The density times volume. Okay, now let us replace this M for density times volume. So here we have density times volume. We can just do, okay, equals what? Z. Then the quantity of electricity is what? IT here. IT. However, we're not given volume. However, but there is area here, and there is a relationship between volume and area. And that is where we need to find the thickness, okay, which is a small dimension of any substance. Okay, so the volume, relationship between the volume and area is given by this, that the volume equals to the product of area times the height. So, but the height here will be replaced by the thickness. Okay, so let us make it thickness. Let us make it as TH. Okay, so which means you have to replace volume by A and the product of A and thickness. So here we have density A, then times thickness, then equals what? ZIT. Take note that we are looking for what? The thickness. So we have to make thickness the sort of relation. So here we have that the thickness, they will give us what? ZIT all over the density times the area. So now this is the formula we'll be working with now to find the thickness. Okay, so then here we have that the thickness will now be Z, which is the electrochemical equivalent of the copper, is given as 0.00033, then times the current, that is 0.5, okay, then times time 100. Now we have to convert this to seconds. Okay, now converting this to seconds, we now have that 100 times 60 giving us 6,000, yeah, then times 6,000, then all over the density here is given as 10 raised to the power of 4, then times the area is given as what? 100. Okay, so to this end, what we all need to do is to start eliminating and simplifying. So this cancels this cancels this, okay, and take note this is 10 raised to the power of 4. Let's say here, by computing, let's say 0.00033 times 0.5 times 60. So this will give us 9.9 times 10 raised to the power of what? Minus 3, then all over 10 raised to the power of 4. And according to our indices, if you are dividing here, this can come over to the top here, but the exponent here we have a negative sign, so you have 10 raised to the power of what? Minus 4. So let me just clean this. Okay, alright, so here we have that the thickness will now be 9.9 times 10 raised to the power of minus 3 plus minus 4. According to the law of indices, since they have the same base, the power will be summed up. So here we have what? Minus 7. Take note the unit here is in what? Centimeter. Okay, centimeter, yeah. Alright, so and we are asked to find it in millimeter. Okay, now for the conversion, so for us to convert this to millimeter, we know that 10 millimeter equals 1 centimeter. And since this is centimeter, all we just need to do is to multiply it by what? 10. So converting the centimeter, value centimeter to millimeter will come times about multiply by what? By 10. Okay, so then the thickness now will now be 9.9 times 10. Since here we have 1 here, so this would be was minus 6 millimeter. So approximately, so this should be 10.0 times 10 raised to the power of minus 6 millimeter. Now giving us this will be 1. Okay, yeah. So here you have so this will give us this will now be this raised to the power of 1, right? So 1 minus 1 plus minus 8, that will give us minus 5. So that will give us 10 raised to the power of what? Minus 5 millimeter approximately. Okay, so if you love what I've just done, please kindly share this video with others, like my page. Thank you, and God bless you. Bye bye.